Okay, so today we're going to talk a little bit about acid-base theory, how we as chemists identify if something is an acid or a base and how they behave towards one another. So most people are pretty aware that acids plus alkalis from kind of key stage 3 study, but we're going to take this a little bit further. So, acid-base theory. What you are looking at here is what a chemist would define an acid as. So for us, acids are things that donate a proton, a H+. Now you will need to think about this carefully. H+, because hydrogen only has one electron and one proton, usually, if it's not an isotope, you would lose that one electron. All you have got left behind is a proton in total. So a H+ we often call a proton because that is very much all it is. So an acid is a H+ donor. So it is a chemical that will give other chemicals H+ ions. And this tends to happen because the H+ falls off the acid when we dissolve it in water. And the presence of water is very, very important. So HCl, hydrogen chloride, when it is a gas, is not acidic because it is covalently bonded. There is 2 electrons shared between the hydrogen and the chlorine, and there is no H+. So it can't be an acid because it can't donate a H+, can't donate a proton. But when we add water, when it becomes aqueous HCl, this covalent bond no longer exists. It dissociates. So that is one of our key words, that idea that it dissociates into a proton, a H+ ion, and a Cl- ion. So at this point, HCl aqueous is now hydrochloric acid. So we would call this hydrogen chloride, we would call this hydrochloric acid because we now have our proton that can be donated. So anything that donates a H+ can be called an acid. So all of those acids you know of normally, nitric acid, hydrochloric acid, sulfuric acid, it's all because they have a H+ that comes off when we dissolve them in water. No water, no dissociation, it is not an acid. So when they're gases or solids, they are not acidic. And you do know this, this very sour sweets are coated in a chemical that, while it is solid, is pretty stable. As soon as you put it in your mouth and it starts dissolving in the water, the H+ is dissociate and you get that really sour taste because the protons are coming off the acid, usually malic acid, to form the H+ ions and be acid, which tastes sour generally. So what is a base then? So the word base tends not to have come up so often lower down the school. A base is a term for anything that will neutralize an acid. So a base can be defined as a H+ acceptor. It will take the H+ that the acid is releasing into the water and accept it onto itself and neutralize the acid, essentially. So a base can be a solid, it doesn't have to be dissolved in water. So metals can sometimes be defined as bases, and you know this. We've all done that reaction where we have magnesium plus hydrochloric acid makes magnesium chloride plus hydrogen gas. So the magnesium in this case is accepting the protons and booting them off to make hydrogen gas. So it doesn't have to be dissolved in water. However, the version of a base you guys are probably most familiar with is an alkali. So an alkali is anything that releases OH- ions when dissolved in water. So to give you an idea, all bases neutralize acids, and alkalis are a specific type of base that, when you put them in water, produce OH- ions, produce hydroxide ions. And obviously in this case, the hydroxide ions are the things that accept the H+, and you get water coming out. And this is why most neutralization reactions produce a salt and water because you have the OH minus ions there, and they are the thing accepting the H plus. So quite often in the acid-base theory parts of your exam, the course, you will come across this chemical methylbenzene, which I've drawn a skeletal form and a displayed formula for below. Now you don't actually need to know what this looks like, but it gives you a little bit of an idea. It's quite a big molecule. It's very, very stable. So this benzene ring is incredibly stable because of the double bonds around it. It doesn't want to react with very much. And you should know from organic chemistry that methyl groups, like most alkane groups, alkyl groups, are very stable. So methylbenzene is a very, very stable molecule. It is also a pretty good solvent. So like water, you can dissolve things into methylbenzene, but unlike water, it's not polar. It doesn't have electrons collected at one end, which, if we remember from our covalent bonding, water has these two lone pairs on the oxygen, and electrons are negative. So actually this end is slightly negative and this end of the molecule is slightly positive. So we would call water a polar solvent, whereas methylbenzene is a non-polar solvent. All of the electrons are spread pretty evenly around this ring, so there's no collection. Carbons and hydrogens haven't got any lone pairs on them, so there's no plus and minus charge. And this makes a big difference when you dissolve your acid into them, because if you remember, we were talking about our HCl, it's going to become our proton and our Cl minus ion. And this is not likely to happen at all if there's no charges to stabilize these. So when you put HCl in methylbenzene, it does not dissociate. So if this goes in here, there is no dissociation. It is not going to split apart into H plus and Cl minus because there's no way to stabilize these charges. It's very, very uncomfortable. Whereas if you put it in water, because you have this polarness, a little negative end, a little positive end, the proton, the H plus, can have all the oxygen lone pairs sticking towards it to stabilize it slightly. So it's a little bit happier, so it will dissociate into water. And same thing with the chloride. The Cl minus gets surrounded by the H's, so the other way around. So all the H's would be sticking towards it, so it is stabilized a little bit. So this means, in terms of your acid-base theory, that HCl in methylbenzene is not acidic. It is not an acid. It will not turn universal indicator red. It will not react with anything because there are no H plus ions. Okay, so it is not an acid in methylbenzene. It is still hydrogen chloride gas, or hydrogen chloride dissolved in methylbenzene, but it is still a covalent compound when it is dissolved in methylbenzene. But when it's dissolved in water, it will become an acid. And this is a key question that they will ask you. So if I put universal indicator in with HCl and methylbenzene, it will stay green. This is neutral. It's not a base, because there's no way it will accept H plus ions either, but it is definitely not an acid. So getting your head around the difference between hydrogen chloride, the covalent compound of HCl, and hydrochloric acid, the dissolved version of HCl that donates protons, that is acidic, is very, very important.